Okay, we're in business. So, I like to think about stripping everything down into what do we need to make an economy. And I think I drew my fabulous island photo. And by the way, if you've got these available, these are the things we'll be working from probably the next couple lectures. What does it take to have an economy? And I argue that we need to have some trade. We need a couple people engaged in trade. So I've got Tom and Jen here on our island. And if Tom was all by himself on the island, you can imagine he can do some coconut harvesting, he can go fishing, so he can produce and consume, right? So he can kind of trade with himself, but he's got limits on what he can do all by himself. And so the benefits of the market and exchange and trade is that both people can potentially be made better off than what they can do independently. So that's kind of the argument that we're going to make here. So imagine what they can do on a given day. So Tom has the choice of, given his time during the day, the best that he can do if he's had a good night's rest, he can go out and collect 8 coconuts or 8 fish, and 8 fish. 8 coconuts and 8 fish. Or on a different day, could get 4 coconuts and 12 fish. So that is his abilities. So what does that mean for trade-offs and choices that Tom faces? What does a fish cost him? So he's got only so much time during the day. First of all, if he's fishing, can he be coconut harvesting? No. So there's the choice right there, right? He's either doing one or the other, one activity or the other. Here's some data that we collected from Tom. On one day, he can do 8 and 8. On a different day, he can do 4 and 12. So we can kind of deduce what the cost of one is. So let's think about the cost of a fish. So what is the cost of a fish? One fish. One coconut. How'd you get that?
8 for 8.
8 for 8?
Sacrifices 4 coconuts to gain 4 fish.
Okay, so now you're coming back over here.
Yeah.
Okay. So let's put those maybe in a little bit different form to help digest this. If we think about Tom's ability for coconut and fish, one possibility, combination A, is to have 8 and 8. Another possibility is to have 4 coconuts and 12. So to think about the trade-offs on a given day, we start to see it this way by going from I can have A or I can have B. So what's it costing me each time? So if I give up 4 coconuts, minus 4 coconuts, I get 4 fish. So putting on some equation goggles, which I don't think I've even talked about yet. I need to go over my theory of math here in a moment. So 4 coconuts is equal to 4 fish. 4 coconuts can be traded for 4 fish internally, right? This is Tom's internal trade-off. All right. So I didn't ask for the cost of 4 fish. I asked for the cost of 1 fish. So what can I do with this equation to get a 1 over here? Divide by 4. What I do to one side of the equation? my 5th grade math teacher told me you got to do to the other side of the equation. And now we've got it. 1 coconut can be traded for 1 fish. So that's our internal trade-off for Tom. That's for A. Well, it's for A or B. It goes, you're using points A and B to establish that trade-off. Okay, so that is his ability to trade one for the other. All right, what about Jen over here? So Jen washes up on the island sometime after Tom. And now there's 2 of them on the island. And these are Jen's production possibilities. What does it cost Jen for a fish? A third? Half? 3? Let's think about it. All right, so let's put it in the same format we did here for Tom. And think, okay, well, Jen's got situation A and B too, coconuts and fish. And these are creating a schedule of numbers. I think I'll take a little bit of time to explain that here. So one combination is 4 and 8 for Jen. Another combination is 3 and 11. So this is what I call a schedule of numbers, or schedule, what I call it really is putting on our schedule goggles to look at math. So we got 3 sets of goggles that I want you to have at your disposal in this class to handle math. And I know math is kind of taboo for some of you, so hopefully this will help a little bit. So you can view math in 3 different ways. So this is kind of a little bit of a side for this. 3 ways to view math. So number 1 is with a schedule of numbers, what I call viewing it with our schedule goggles. This will usually be a list of numbers. You guys saw this in 4th grade where we had the X and the Y and we said 5, 6, 7, 10, you know, a list of numbers. That's all we're doing here, right? We got a schedule of numbers. We also can take that schedule and graph it. So we can use what I call our graphing goggles to view that same problem. Again, kind of simply going back to our math class of x's and y's, I can plot these points. X equals 5 and y equals 6. X equals 7, y equals 10. I got 2 points on there. Maybe I have more numbers and I start to see a collection of points or some sort of line like a supply curve or like something else that shows a relationship between x's and y's. Now in econ class, I got good news for you. I don't stick to x's and y's very often. So we'll be talking about x-rays and yo-yos, pizza and beer, you know, stuff that hopefully applies to the real world in some way, shape, or form. So this will be one of the last times I use that. In fact, I go so far because I want you guys to stay away from that, calling this the horizontal axis, not the x-axis. And this is the vertical axis. So all the way down to the labels of what maybe is already imprinted in your brain, and that might be hard for you to break away from, but this is the horizontal axis, which could be measuring potatoes, and this is the vertical axis, which could be measuring beer. Our last set of goggles we can use to look at math is with an equation. So our last set is our equation goggles. And we will do a little bit of equations in here as well. So anything that you can put into this type of form could also be represented with some sort of equation. Now, for a simple line, that equation could take the form of slope-intercept form. Y equals mx plus b. You might remember that one. We do need to know slope. Great time for me to put an advertisement out for the first chapter 1 appendix is the math review appendix. I also have a quiz that all of you need to get at least 70% on before you proceed on with class. That's online on My Econ Lab. You need to score at least a 70% on that quiz to proceed on with the class. There's just kind of this minimum threshold. So hit the math review, the appendix. Those of you who think you're pretty comfortable with math, you might be able to give it a quick look. I think it'd be helpful for you to look at it too, though. It talks about all variations of things we might look at with a scatter plot and interpreting data, positive, negative relationship, when things have curves. I mean, I don't mean to be throwing a lot of stuff at you. I think it's laid out in a pretty easy form, but make sure you take a look at that. So slope, I'm going to use good old rise over run. So we could say change in y over the change in x. You guys saw a lot of different ways. Maybe that your math teacher talked about slope. I like good old-fashioned rise over run. So in this case, the slope of this line with these 2 points is we're rising 4 and we're running 2. So 4 over 2 equals 2. The slope of this curve, if it's a line, is 2. We are going to do some rise over run right away coming into this chapter 2 and chapter 15 with the international trade. So get comfy with it quickly. This part of the equation was the vertical intercept. All right, so what's my point with this? Anytime you see math in your book, it'll come in one of those forms. Let's see, I did take my book out. Who's got a book here? Just drum to a page here. So, let's see here. What do I come to first? Usually doesn't take this long. Ah, there's something. Aggregate demand. So you'll come to a graph, and you're supposed to work with that graph. What I want you to remember from today is that in the back of your mind, there's 2 other alternatives to viewing this problem. That particular graph could be represented by some equation, or it could be represented by a schedule of numbers. You can go back and forth between the 2. You're just looking at the math differently. Okay? So 3 ways to think about math in this class. All right, back to Jen. What is Jen's cost here? We got our schedules goggles on. And we can go either way with this, but Jen can get 3 fish if she gives up 1 coconut. So look at these trade-offs. Sometimes we'll have longer lists than this. Those are the trades that she can do internally. And so over that range, 1 coconut equals 3 fish. But I didn't ask for the cost of a coconut. I asked for the cost of a fish. 1 fish, specifically. So you having my equation goggles on, I can get a 1 over here by doing a little division. What I do to one side of the equal sign, I got to do to the other side, and boom, it pops out at you. 1 fish costs Jen 1/3 of a coconut. All right, let's step back from the problem here. What can you tell me about Tom and Jen in general on their skills and abilities with these 2 goods? Is anyone better than the other at something? Tom's better at both, right? So on a given day, we've got 8 and 4. So while Jen, whoops, yeah, I can leave that one down. While Jen can only pull down 4 coconuts while doing 8 fish, Tom can pull in an additional 4. And same thing on the fishing side. So he can have more of both. So we call this an absolute advantage. I've stacked the deck intentionally to try to prove how 2 parties can be made better off even in the case where one person's better at both things. So we've got Tom here better at fishing, better at coconut harvesting. The idea would be, why would Tom ever want to trade to Jen? He's better at both. Can't he just do them both? Well, he can do them both, but Jen can do them both too. So we've stacked the deck so that Tom, on the face of it, might be anti-trade and say, well, forget that, I'm better at you at both anyway. We've already learned something here by calculating these trade-offs. Who has to give up less to go fishing? Who has to give up less to go fishing? Jen. So Jen has an advantage over Tom, not an absolute advantage. Tom's better at fishing and better at coconut harvesting the way we've stacked the deck. However, Jen has a comparative advantage in fishing in the sense that if she goes fishing, she gives up less than what Tom has to give up. So Jen has a comparative advantage. A comparative advantage in fishing. So Jen has a comparative advantage in fishing. Now we kind of see something else going on over here. Tom had the 1-for-1, so it costs one fish costs Tom a coconut. We already learned over here that if Jen goes out and harvests the coconut, it costs her 3 fish. So to go coconut hunting, it costs Jen 3 fish, it costs Tom 1 fish. So Tom has a comparative advantage in coconut harvesting. And now we start to see how we can make each other better off. And the light bulbs maybe go off for both parties and say, hey, I was just thinking about how we fish and hunt coconuts, and I bet we could do better off if I'll go do the fishing, you go do the coconut harvesting. We start to specialize in the thing in which we have a comparative advantage in. And potentially then, when we get back together at the end of the day, we'd have more than what we would do on our own to divvy up or to trade. So that's our setup for the benefits of trade. Questions so far? May seem like we're spending a lot of time on a little thing, but as situations get more and more complex, they still boil back down to Tom and Jen on the island being able to make themselves better off through trade than acting independently. All right, so let's graph them out. So here's our graphing goggles. You guys have your sheets hopefully in front of you. If you don't have your sheets, you can just draw a quick graph. All I've done now is mapped out my schedule. I went from my schedule goggles to my graphing goggles and mapped out point A and point B for Tom. And now you see the trade-offs in terms of slope. Rise over run, down 4 over 4, which is exactly what we saw in this equation right here. 4 coconuts equal 4 fish. We're doing the same type of thing graphically now. questions on that? Jen, same thing. Point A, point B. Give up a coconut, get 3 fish. There's our trade-off for Jen. All right, so in the grand scheme of things, how could we make each other better off through specialization? We can fully specialize in the good in which we are best at by moving from a point A or B to all coconuts. So if we assume that that trade-off, which is a little bit of a simplifying assumption, that if we spend the whole day now exclusively doing coconuts, Tom can make this much. How much is this much? Look at your numbers, think about the time, think about the trade-offs. What is the max Tom could kick out? 16, right? So he's got a 1-to-1 trade-off. So whether we start at point A or point B, it doesn't matter. If he's currently got 8 coconuts and 8 fish, if he gives up the fishing, he'll get 16 coconuts and 0 fish. So our schedule would possibly be some other point. I'm just making up a point here. Point E, oh wait, I do have a point I think in the graph that I'll do. Point C would be at 16 and 0, maxing it out. I'm just kind of squeezing in our intuition here as far as the schedule. 16 and 0 is a production possibility for Tom. 8 and 8 is another production possibility. 4 and 12 is another production possibility. We do the same thing for Jen. Jen is coming down here, maxing out fish production. So here's our point C for each individual. Jen would max out at 20 fish. Tom max out at 16 coconuts. At the end of the day, we can get back together and maybe do some trading with each other and make each other better off. All right, these are the production possibilities curves. Your textbook goes over an example of 2 people with ice cream and something else, kind of goes through a similar one. So you can get a second dose of this from the text towards the end of chapter 2. And then where we're going ultimately is this is going to be the United States, and this is going to be Japan, and the 2 countries are going to be trading cars and rice or something like that, right? So that's where we're ultimately going. We're going to scale this thing up, this concept of comparative advantage, and show how countries can be made better off through doing the same thing. All right, so we can think about it, our island production, which is somewhat what we do in macroeconomics. We said that we're going to talk about the whole society, the whole island in the United States. And if we just have Tom and Jen now, we can think about the island's production possibilities. And if Tom does all the coconuts, Jen does all the fish, one production possibility for the world, our world being our island, is this point XC. So here we are at 16 and 20. That is 1 point on the island's production possibilities curve. Tom and Jen can choose to be at any point they want. Suppose they are sick and tired of coconuts and coconut milk, and they say, you know what, let's just fish all day together. Screw it. Screw the coconuts. If they do that, they could have 36 fish, right? So 20 coming from Jen, who already was maxing out. Tom saying, screw the coconuts, I'll do the fishing too. We could be at 36 fish. So again, this represents the island's maximum production of fish. That's possible. A production possibility in fish production is 36 and 0. All right. So let's think about how we reorganize society in terms of where production takes place, how production takes place when we start to need a little coconut milk. So when we're here at 36 and we decide we want some coconuts, who goes out and does the coconut hunting? Tom or Jen? Tom, right? So you see how we've changed the game a little bit now, that we know that Tom has the comparative advantage in coconuts. He's the best at coconuts. So from society's standpoint, the resource that I want to plug into that production is Tom, that unit of labor, because it's going to be the most efficient way to get a coconut. It surrenders the fewest amount of fish. I give up a fish, I get a coconut, if I'm using Tom. If I'm using Jen, I'd have to give up 3 to get one. That would be kind of foolish. So I'm going to continue to use Tom until he's maxed out. If I want further coconuts, I've exhausted my limited resource of Tom, and now I have to send Jen out fishing. And I'm going to give up 3, and I'm still going to get another one. Give up 3, give another one. Give 3, all the way up to this point. So this represents society's potential or production as well as consumption. That's the world production possibilities curve. Questions on that? Check out these inside points. These are non-trade points. Well, all I did is I said, suppose they hate each other and they just want to do their own thing. Where does production end up? Well, if Tom does A, 8 and 8, and Jen does A, 4 and 8, XA is the sum of their individual productions, right? I'm just calling it XA arbitrarily. And this is the point, and this is where it sits. If both of them do their own thing, not coordinating efforts, not engaging in trade, Tom's at B, Jen's at B, XB represents that point. I didn't graph them here, but I could do, suppose Tom's at A and Jen's at B and vice versa. All those points would start to fill in somewhere in here. And the point it's illustrating is that through trade and exchange, they could be here, which is a superior point to XA. Why? Why would XC be a superior point to XA? You're getting more of both, right? So you got more of both without having any more resources, right? Usually we think about, well, if I want something more, I need more inputs. That's the waste, or what's left on the table by people not engaging in trade, right? So that's what makes this an efficient point, is the fact that any other point doing some other system, whatever it is, leaves you with less things that you could have using the same amount of resources. All we have is Tom and Jen. Resources are fixed. Economics, the study of trying to satisfy unlimited wants with limited resources. I haven't changed the resource base, but I'm able to, through restructuring who's doing what in the most efficient way, I can have XC instead of XA. Cool. That's pretty awesome. Hopefully that'll sink into your life sometime and you'll say, wow, you know what? That was freaking cool. All right? Here we had a fixed amount of resources, and we're able to kind of reorganize things through trade and make some people better off. All right. So, suppose we're there. Tom's sitting with 16 coconuts. Jen's sitting with 20 fish. Now we need to trade. How does that go on? Well, let's say they don't really care for each other. This isn't a boyfriend-girlfriend thing where they all just kind of, let's figure it out together. This is like hardcore business. They're like, okay, listen, buddy. I just spent the day fishing. I got 20 fish. You got 16 coconuts. Let's talk. Right? So let's think about the incentives of each. So Jen would like a coconut. She's sitting here with all fish. She owns them. There's property rights that are well defined. Tom can't steal these fish, right? So the only way they can do it is through a mutual voluntary arrangement of trade. So Jen could always go get a coconut herself. What would it cost her? 3 fish. So if she's going to do any trading whatsoever with this guy, then she's got to get less, pay less than 3 fish. So the maximum she's willing to pay is 3 fish, because otherwise she could just do it on her own. She's not better off unless she gets something less than 3. On the flip side, Tom, being our seller of coconuts, needs at least 1 fish to make it worth his time. Otherwise, he could just do it himself. So he's got to get at least 1 fish. Voila! A market is born. We're talking prices now. I know I haven't entered any dollars, but these are prices, right? We've got someone who needs at least 1 fish, someone who's willing to pay up to 3 fish. We have a spread. We have a market. A market is born. These two can negotiate with each other and come up with something in between. That's the market. No matter what price they strike, as long as it's between these 2 points, both will be made better off. So we have some wiggle room here on making both parties better off. It doesn't matter if it's 2, or if it's 1.5, or if it's 2.75. That's up for negotiations. Now, Jen, of course, is going to be made better off the cheaper she pays for it, right? So there is some level of that. But at the end of the day, starting with this position, both parties will be made better off no matter what price we end up at. All right, questions on that? The birth of a market. We got supply and demand going on here all over. All right, so back to our graph. We can show the power of the trade this way. If both of them are acting independently, the production possibilities are equal to the consumption possibilities. It's kind of a self-sufficient thing. What you produce is what you eat. What you produce is what you consume. So that'd be anywhere along A and B is where Jen can be. Anywhere along this orange curve is where Tom can be. Here's the beauty of trade. So if they come to terms on a price of 1 coconut equals 2 fish, remember I'm just arbitrarily picking somewhere that's in the middle. Who knows how that price came to be? This is how that trade would map out. Jen used to give up 3 fish to get 1 coconut. Now she gets a little bit more. Tom as well, same thing going on. If Tom gave up a coconut, he would only get 1 fish. Now he gets 2 fish. And the consumption possibilities are now greater than what you could do yourself. Even for our hotshot Tom, who was better at both goods, through engaging in trade, even with somebody who doesn't have as good of skills as he does in those areas, he can be made better off, she can be made better off. They both now have consumption possibilities that are outside of what they can do on their own, and they did it by simply specializing in what they're good at and trading for it. So in the grand scheme of things, that's capitalism, a market-based system of allowing people to engage in trade, act on their own self-interests, and make themselves better off. All right, we'll call it a day there. Got Monday off, so we'll see you Wednesday. Remember, your first homework's due tonight on My Econ Lab.